All right, people, let's look at how ions are related with regard to your models of Bohr, orbital, longhand configuration, shorthand configuration, and Lewis dot. Okay, and really we'll probably just focus on orbital, Bohr, and longhand because I don't believe Lewis dot is factored in with your ions on the exam. But, okay, I'm going to erase the work that we had here. Cut. Okay, first block, especially since you guys had this lecture, I actually explained it in the reverse fashion, so hopefully you guys are catching this video beforehand. I'll put a little note in Schoology just to remind everybody to watch the video. But the way that it was explained in class, and I'm going to change my tune on here, is like, let's say that we're looking at iron. Iron is the sixth element in the D block, so 1, 2, 3, 4, 5, 6. Iron is really right here. So iron's electron configuration finishes at 3d6. So we're going to write out the full configuration for iron as if it was not charged. So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So this is neutrally charged iron, right? If I were to do the orbital structure for this atom, it would look something like this. So we go arrows, they're going to have opposite spin. Every orbital gets 1. Okay, here we go. So 1, 2, 3, 4, 5, and 6. There's the orbital structure. If we were to do the Bohr structure for this, which I don't have a ton of room. I'm actually going to erase the work that we did prior here. Let's cut. Okay, we're going to look at iron. We go 1, first shell, second shell, third shell, fourth shell. Now, just so you don't have to watch me draw in dots, I'm just going to write in numbers. First shell has 2, second shell has 8. The third shell has 2 plus 6 plus 6, so that is 14. And then the fourth shell has 2. These are all representing electrons. I'm just writing out the number instead of the dot because it's going to take a little bit of time. Okay, that's neutral ion. Now, if we were dealing with a positively charged iron that had a +2 charge, let's say. I think this is the example I used in first block. If we're dealing with iron +2, watch closely how it changes. I'm going to duplicate this configuration. Now, the electrons that get taken away if it's a positively charged ion, in this instance, has to come from the most outer shell, which in this case would be the 4s shell. Okay? So you would effectively remove the 4s2 as we just did right there. And then this kind of would just go right here. Okay, if we look at the orbital structure, even though 3D is higher on the energetic pathway than 4s, this is the outermost shell, so this is where those electrons are being removed from. Okay, and then if we were to go down here and remove off of the Bohr structure, we're removing those 2. Okay, that's if it's a positively charged ion and you're involving the D block. you're going to pull from still that outer shell. Even though this, this 3D has a higher energy level than the 4S. Okay, now that runs counter to the explanation that I gave for first block. So first block people, make sure that you're paying attention and you're watching. Adjust your thinking on this. I consulted with some of the higher ups in the chem team and was enlightened. Okay, now if it's a negative ion, it's still the same way that we explained. A negatively charged ion, if we were to use that as an example, so let's cut, not the image. Let's cut here, cut, and cut. Like let's take fluorine, for example. So fluorine is up here in the top right. So I'm just going to erase the iron, erase my notes there. So fluorine, element 9. If we were to write out the longhand configuration for just fluorine, not the ion, just neutrally charged, it's 1s2, 2s2, 2p5. Now the ion that fluorine's going to form is fluorine minus 1. So that goes 1s2, 2s2, 2p6. Okay, this is a little bit easier to understand. If we're to compare then the orbital structure, it's less arrows obviously, so let's take it down. Neutral fluorine would have an orbital structure similar to this. Okay, fluorine minus 1 means you're gaining an electron, so we would put that arrow back. This would represent the orbital structure for fluorine minus 1. Okay, same idea, same understanding for the Bohr model. Let me just erase our notes here. It only has 2 shells here. First shell would have 2. Second shell would have 7. This is just for neutrally charged fluorine. Okay, and then if it became fluorine minus 1, aka fluoride, you're just going to gain that extra electron. Now it satisfies the octet rule. It has 8 in its valence shell, and this ion would behave like neon. That's why I had that arrow up here pointing to neon. Fluorine's electron configuration then matches neon, and neon's a noble gas, so fluoride is pretty unreactive in all cases. Okay, I hope this helps. Please email with questions. The next video is going to talk about the relationship to atomic radius and ions. Thank you much.